Hey everyone, Dave here. So today I want to finish up our NEP-5 kind of basics here. And one of the last things we want to do is implement the event of transfer. So this is the event we have to implement, and it is going to fire whenever tokens are transferred, including zero value transfers. And we'll talk about how when you create and destroy tokens, what to do there as well. So the reason for this event being fired is actually it just does a runtime.notify is all it's really doing underneath it all. But you can write clients that listen to notifications. So this would be perfect for an exchange to listen to the transfer event and say, oh, an amount went from this account to this account. Are any of those accounts on my exchange? If they are, I can update the balance here. Now, there's nothing to stop you from creating some sort of bogus transfer method or having a bug in this. So if I was writing an exchange client, I would double check the balance, but I would use this notification to say, oh, I should check this balance. So instead of basically having to scan through every single person's balance every minute and checking the blockchain to see if it's changed. So what I'm going to do is put this method in here. So we could just create this event without this display name on it and call it transfer with a lowercase t here. I don't like that. So what you can actually do is you can use this display name of transfer. We'll make it so that when the event fires, the message that's going to be run is called transfer. So here we've got transferred. Now, because at this point we've run down to here and we should have succeeded, we are going to invoke the method. Transferred. Oops, this is. We want to say who it was from, who it was to, and then the amount. And that's it. Now, if you're a long-time developer, you will say, well, you did not check to see if this event was wired to anything. You should have if transferred is not equal to null to make sure that it's attached. This will not work. The nice thing, or the bad thing, I don't know, with Neo is it's always going to wire up this event, and I'm sure it's taking events and doing some sort of trickery, because actually what you can do is use runtime.notify from to amount. That's all that seems to be doing to me. So I do leave it as an event just because it's maybe a little easier to read and it kind of follows the standard. But you know, that's debatable of how you want to implement that. As long as a notify message appears on the blockchain called transfer with from to an amount, that's all we really care about here. So, oh, I haven't rebuilt this. That's why it's not prompting me here. So we'll build that. I'm just going to bring that back up here. So some of the things with this transfer method here is if you are creating new tokens, you should trigger a transfer event with the from address of null when tokens are created. And if you are burning tokens or destroying them, you should create a transfer event with a to address set to null. So that's allowing anything tracking your contract to know that tokens were created or destroyed. So we'll do that here in a minute. Let's bring up the debugger here. And I think we probably do still have our transfer method in there, which is great. It's going to run true, debug, so it returned true. And you'll see here in this log was this method that ran here. So you'll see that we got a D, that is, I guess, our hex encoded 1, although I thought hex encoding would have 2 digits. So a little bit wonky there. So we will have to test this on the actual blockchain at some point, but the debugger makes this a lot faster. Now, I was just talking about creating and destroying tokens, which is something that we do in our initialize method. Where's our initialize method here? Is we create tokens. So transfer from null to owner and the amount. So you can see here that our total supply, we've started to use this in a few places here. I would extract that out to a variable. I'm not going to bore you with doing that here, but that would make it easier to change in the future. So now here we've got a transfer event that will fire. And let's just have a review of this. We're not burning any tokens, but if we had a method in here to burn them, we could. Anything else we do, we are checking to make sure that it's false at the account balance. It must fire the oh, right. If the amount is 0 or the from and to are the same address, this is one of those weird little spots here. So if amount equals 0, amount even, so if for some reason someone were to call this and say they wanted to transfer an amount of 0, we're supposed to still fire the event and say that it was successful. Technically, I could send $0 from me to you, and that's okay. I don't know why, but that's okay. So why anyone would do that, I don't know. The other thing is, if from equals 2, so you're sending from yourself to yourself, we're also going to return true there. So I found actually a bug in a contract that I wrote where you could send funds from yourself to yourself and it created funds out of thin air. So if I sent 1,000 tokens from myself to myself, suddenly I would have plus 1,000 tokens. Actually, no, it worked a little bit differently. I think I ended up with, it would take away 1,000 from me or something like that. But yeah, just a little wonkiness for in my logic. So this is kind of a nice check to have in there. And I think that is it. We have a basic NEP-5 token. We've got our checks in here. We know who we've validated our input, which is always important. We've made sure the caller is who they say they are. We've allowed for 0 amounts, transfers to self. We've made sure that you've got the funds to actually transfer, and then we change the from and to balance and we fire off the event. So there we go. We created a NEP-5 token. It's fairly straightforward. The big catches I've found developing these contracts over the past little while has been finding out what you can do in the VM and what you can't do. So you can use a lot of things in C#, but then you try and use something you think you can, and it just does not work. So, you know, that's just the VM doesn't have an operation for that yet or ever. You know, a good example of that, generating a random number. You know, you can't use the random class in C# because the Neo VM does not have an operation to generate a random number in it. So it does not know how to translate those two. If you do want to get a random number, can I do it off the top of my head? I think it's blockchain. Get header? No. Man, I cannot remember how to do this. This is on the NEO website. But basically what you do is you get the current block, and it will have a random number in it. Yeah, sorry. Shouldn't have even launched into this here. You can Google for this. It is documented. But the way this will work is that every block that gets generated will get a random number associated with it. So the consensus nodes are basically going to pick a random number and give that to the block so you can use that in your code. So every block will have its own unique random number. And you can use that throughout. So that means that every block, every transaction within a block will have the same random number that it will get for its source data, which is probably okay, but just something to be aware of. So I'm going to wrap it up there. That is the core of NEP-5. I'm going to talk in another video about the third-party transfer methods that were removed from NEP-5. So hope to see you for those. Thanks, everyone.